Welcome to this brief demonstration of the OsmoCalc Osmolality Calculator. To begin, I'll assume that you've installed the program and we can start from the Windows button and enter Osmolality Calculator as one of the installed apps. Click Open and the calculator will begin. We see the nutrient grid for, in this case, a milk replacer mixed with water to calculate osmolality. The columns will calculate the osmolality for each of the components, the CMR and the water osmolality, and total osmolality as well. The first row is the number of grams per day that is being fed, and in this example we begin with 650 grams of milk replacer powder on an as-fed basis, and 5,350 milliliters of water to provide a total volume of 6 liters, or 6,000 milliliters. The dry matter concentration of the milk replacer is shown here, as is the water solids concentration. Now, this is expressed on milligrams per liter, so it's a different unit compared to the concentration of the CMR. Note that these numbers are all expressed on an as-fed basis, so it's easy to calculate the values from a feed tag. In the default example, we have a 24% protein, 18% fat milk replacer that contains 8% ash. The other components such as starch, NDF, dextrose, and others are assumed to be 0%. Now, the lactose concentration contributes most to osmolality in typical CMR formulas, so calculating it is important. Unfortunately, it's not usually provided on most feed tags, so we need to estimate it. A reasonable method to estimate lactose concentration for high-quality CMR is to calculate as 100 minus water, protein, fat, and ash. So if I do that math, it will calculate to 45%. I then enter the mineral values that I get from either the feed tag or from some standard values. Let's look at the concentration of a typical milk replacer. We'll use a feed tag that's available in the feed industry. Here we have a 22% protein, 20% fat CMR from the United States. Regulations require these nutrients be displayed, but we are lacking several important osmotically active minerals such as potassium and sodium. We see there's a minimum and maximum calcium of 0.75 and 1.25 respectively. Since we don't know the actual value, we split the difference and enter 1%. The minimum phosphorus is 0.7%, which I will also add. To calculate osmolality, we need more than the calcium and phosphorus, so we're going to have to estimate many of the mineral values. One of the ways we can calculate those is to go to CAF note number 243. The second table contains a list of the recommended mineral concentrations for CAF milk replacers. We see here the calcium is recommended to be 0.8%, phosphorus 0.6%, magnesium 0.15%, etc. So we can use these as some guidelines to replace the missing values that aren't available on the feed tag. They should be relatively reasonable estimates. Now note, these are entered on a dry matter basis, so we have to correct them to put them on an as-fed basis to work inside the calculator. Once we have the composition of the CMR and we know the number of grams per day we're feeding, we can calculate the number of milliosmoles, or MOSM, that are provided by the milk replacer. And you can see overall there's 1,525 milliosmoles provided by the 650 grams of milk replacer. The water contains a little bit of solids and a trace of sodium and calcium. You can likely get these numbers from water tests taken on the farm or from some standard values. Note that the contribution of milliosmoles from water is generally very small. In this example, there are only 16 milliosmoles contributed by the water. So the total then is 1,541 milliosmoles, almost 900 of them coming from the lactose in the mix. And we can see that the osmolality in this example is 257 milliosmoles per kilo. Now, this is a relatively dilute solution, only about 10% solids, so I might change this. I can express this in a different format, as in the ratio of 150 grams of powder to 850 milliliters of water to make 1 kilogram of total. You can express the values in either format. Once I've changed the feeding rate to 150 and 850 grams, our osmolality is 354. We're still within the green zone. This is a relatively safe formula. The osmolality of whole milk is between 280 and 300 milliosmoles per kilo, which is considered isoosmotic. And most research suggests that when we get above about 450, we can have negative effects on abomasal outflow and cause digestive problems for the calf. If I continue to increase the solids concentration, let's say to 18% solids, now I'm definitely increasing the osmolality and am approaching that danger zone. Because most osmolality is derived from lactose, as I change the protein, fat, or ash values, I will change lactose and change the osmolality. Well, this brief example demonstrates how the program works. There are many more options to estimate osmolality of CMR, whole milk without or with additives, and even a method to include additives like electrolytes. There are other demos in the knowledge base to further demonstrate the capabilities of OsmoCalc. Go to the OsmoCalc homepage and click on Support to view more demos and other useful information about the program. That'll do it for now. Thanks for watching.